All right, so let's take a look at the national debt right here. And this was taken at 1 o'clock today, October 28, 2024. And, there's a lot of numbers going on here, and most of them are pretty significant, okay? But for our purposes, really the only thing we really care about right now is just this number right here, okay? So we're just looking at the U.S. national debt. Of course, we are going to be only looking at it in terms of billions right there and anything to the left. So billions, 10 billions, 100 billions, and then trillions and 10 trillions. Now that should worry you. We're pretty much saying that the only significant numbers are billions and above. And so if you look at the original number, which had 692,291,312, that's indicating that those numbers are insignificant. Not only that, but we rounded this down just to be a little bit more conservative with what we're trying to do today, okay? So what is it that we're trying to do? Well, you could change this into scientific notation. That's why this number is as big as it is, and it usually goes along with a scientific notation type lesson. But that's not what I'm doing. What I'm going to do is I'm going to take this number here, which is the approximate debt, national debt of the U.S. at 1 o'clock p.m., October 28, 2024, rounded, kind of. And what we're going to do is we're going to find how long this is in stacked $100 bills. Well, stacked $100 bills, how does this work? They say that if you take stacked $100 bills, a 40-inch stack of $100 bills is worth $1 million. Now, I obviously don't know that because I've never had $1 million, and heck, I don't even know the last time I saw a $100 bill for that matter. But if you had $100 bills stacked, not lined up end to end or side to side or something like that, it's taking them and stacking them one on top of the other. You'd have a 40-inch high stack of $100 bills. Now, that's $100 bills, and that's, that would be pretty freaking awesome. But what we're going to do is we're going to figure out the height of this in inches first. And since we're not going to be able to really realize what that means, then we may expand into feet and miles. That's what we're going to do. Keep in mind as well that this number right here does not include unfunded obligations. It only includes funded obligations. So an unfunded obligation is money that the U.S. owes but has not paid out and pretty much will never have the money to pay out anyways. Keep in mind as well, this is 35,831,692,291,312, according to the economist Anthony Davis. He said that if you had $20 trillion, you would be able to go through every store in every city, in every town, in every place in Europe, the entirety of Europe. So that includes France and England and Spain and all the other countries in Europe. And you would be able to buy everything off of every single one of those shelves in every store, in every city, in every country. So that's quite a bit of money. And from this, you should be able to think, well, how much of this money did I actually get? It's not really that is not really the question that you should be asking. That you should be asking, well, what does this do to the money that you have? And that kind of expands out from what we're trying to do in this problem. I'm just trying to show you the sheer magnitude of this number, but rounded down, okay? Because again, we're trying to be a little conservative with our estimates right here, just in case maybe instead of 40 inches, maybe it's like 39.86 inches tall. I can't confirm that one way or the other. Okay, so what we're going to do first is we want to figure out how many millions are in that number, in the debt, okay? So to do this, what we're going to do is take that number and we're going to divide it by 40. We're going to divide it by 1 million because that would tell us how many millions are in that original debt. So I'm going to type this into my calculator. 35831,000,000,000, and I'm going to divide it by 1000000, enter. And this is the number that it gives me in millions, okay? So this is how many millions are in the national debt. Now, for those of you wondering, this is, let's see, that's 35,831,000 millions inside of the national debt. That's a fairly large number. It's a very large number. Okay, so what are we going to do with this number? Well, we're going to take it. This is how many millions there are. That's how many millions there are. And we're going to we're going to multiply this. Multiply this by 40 because this is how many millions there are. There are 40 inches every $1 million. And so if I multiply this by the 40, this will tell me how many inches are in the national debt. So I take that number and multiply it by 40. This is the number that my calculator gives me, and that is in inches. Okay? So what is that number? Well, if I can put my commas in the right place. Let's see, thousands, millions, billion. 1,433,240,000 inches, which is quite a bit of inches. In fact, that number is so large that I cannot actually comprehend what that is. So I'm going to change this number into feet and see if that helps me out. So I take my inches, and I know that there's 12 inches in every foot. So really what I'm going to do is I'm going to take that number and I'm going to divide it by 12. And this will tell me how many feet are in the national debt for stacked $100 bills. So I take that and divide it by 12, and this is the number that it gives me in feet. And my calculator has rounded that, it's rounded it up in feet, but remember, we're missing some millions of dollars, so we're going to say that that's going to be allowed. Okay, now that's the number of feet, and let's see, how many feet is that? That is 119,436,666 and 7/10 feet. But, again, I can't really picture that in my head. And I suppose that even though I'm going to expand this, I probably won't be able to picture anything else in my head, but let's find out if we can just see if it helps to see this number in miles. Well, so we're going to do the same thing. We're going to take these number of feet. There are 5,280 feet in every mile. So I'm going to take that number and divide it by 5,280, and this is how many miles it tells me that that the national debt is in stacked $100 bills, 22,620.58. We'll round this to the nearest hundredth in miles. Well, that right there is quite a number. So that tells you how many inches that was and how many feet. This is a little bit more, hopefully this is a little bit more easy to tell what this number is. Now, I think it was 3 years ago, I did the same kind of calculation for the national debt. Back in those days, 3 years ago, the national debt was, I believe, was $28 trillion. So it's increased 25% since then. 25% of $28 trillion is $7 trillion. That is massive. But this number also is quite massive in miles. And so it may be helpful to think in terms of the context of that number. Well, if we were to look at the circumference of Earth, the circumference of Earth is about 24,900 miles. Okay, so that means that we're off. Let's go to my calculator. 24,900 minus 620. I'm not going to use the decimal here. But that means another 2,280 miles of stacked $100 bills, mind you. And you've gone completely around the earth. Remember, please remember, this is in stacked $100 bills. So, of course, if you took the length of each dollar bill and made them end to end or side to side, I mean, geez, this number is approximately a tenth of the distance to the moon. So, of course, you'd be looking at going past the moon if you were to stack them side to side or end to end. This is a large number. And if you don't know what the national debt does to your dollars, the dollars in your pocket, then you better learn, because it's a way to rob people of money. You could have a stack of cash, you could put it in a safe, you could sit next to that safe with a rifle and say, I'm going to guard this, and then if the national debt increases, essentially someone has reached into your safe and taken out money. Another way to help, because I've had students ask about this in the past, well, what does this mean? What is this? I don't understand. If the number goes up, why does that make a difference? Why does that make the money worth less? Which, again, is another form of robbery. Well, it's kind of like taking a cup and saying, here's orange juice in this cup, but it's only a fourth of the way full, okay? And it's like taking water and pouring it into that orange juice. Now, you have more juice, but it's not as strong as an orangey taste as you would have had before. That's what's happening to your dollar bills as that number goes up. So you should ask yourself, have I ever gotten any of that money? If I have, how much did I get? Did my parents get it? Who got this money? And it's possible to find out a little bit about where this money goes. It's more important to find out where it comes from, because even though the United States says it comes from the government, it does not. It comes from somewhere else. But again, that is more for your economics type classes, which I'm not going to cover at this time. So there you have it. The national debt at approximately 1 p.m. on October 28, 2024 was about 22,620 miles long in stacked $100 bills.